region of interest. The region of interest. So, the question is this. On these functions that we're graphing, and this is basically every lesson for the rest of the year, when is all of the interesting, are you okay? When is all of the interesting stuff going to happen? Like, how big does our graph have to be? How far do we go? And so, we will find out how to find the region of interest today. Here's the idea. So, let's start with a function y equals x cubed plus 4x squared plus x minus 6. When is all of the interesting stuff that this function will ever do going to happen? Thoughts? When's all the interesting stuff going to happen? What x values? What do you think? I have to remember if I remember how to do this.
I got it. It's religion.
You guys doing okay?
No.
No? I'm sorry. Hey, I do remember how to do this. This was cool.
Are you a little thirsty?
I'm teaching right now. Thank you. Okay, the region of interest is this. Oh no, I don't have any other colored markers. I guess I'll have to use the same color, and your educational experience will be decimated because of it. So, look here for the biggest number. What's the biggest number you see? We got a 1, we got a 4, we got a 1, we got a negative 6. Biggest number is? The largest in math, absolute value. Negative 6, right? So, what I'm going to say is that all of the interesting stuff that ever will happen in this problem or in this graph will happen in a circle of radius 7. So just add 1 to that number, and you have where everything interesting about that problem will ever happen. So that includes where this turns, where any zeros exist. All of that happens within a radius of 7 from the origin. Okay, so take the highest number, add 1. That's when everything interesting about this whole graph happens. Not too bad, right? So from there, if they ask you to graph this, what I would recommend, since I don't see a good way to factor it, is just start plugging in points, and then you'll be able to graph. So our first point, if we plug in 0, we would get, what happens when you plug in 0? You guys got this. Oh, you're used to watching it on video, so then I pause, and then you expect me to give you the answer. It's not working that way today. So when you plug in 0, what do you get? Okay, one person. ¿Cuántas? Victor?
-6.
Tavares? -6, right? So that's down here. What happens when you plug in 1? 1 plus 4 plus 1 minus 6 is, Emma? I caught her mid-yawn. It's over. Micah? What happens when you plug in 1? 1 plus 4 is?
5.
Plus 1 is?
6.
Minus 6 is?
0.
So that's the point. Okay? What happens when you plug in -1? The Risa, you're mid-sneeze. God bless you. What happens when you plug in -1? You have -1 plus 4 minus 1 minus 6. What do you get? I get -4. Is that what you guys get? Are you okay? I get -4, right? Because -1 plus 4 minus 1 is negative, or positive 2 minus 6 would be -4.
So you're putting the -1 in the places where...
Oh, it's like the little box thing.
You're just plugging in the x's. Yeah. So the even power will make it positive. So what happens when we plug in 2? Like we can literally plug in all of these numbers between -7 and 7, since we know that that's where everything interesting about this graph is going to happen. And then we can figure out approximately what it looks like. What about negative 2? What do you get? Negative 8 plus 16 is 8. Minus 2 is 6. Minus 6 is 0. How about negative 3? Negative 27. You got this. Plus 30. Plus 36. Minus 3. Minus 6 is ugly. Okay, let's try negative 4. And you keep plugging in these numbers. You find out this is a 0. The best way to do this would be to use synthetic division. So you do your little chart, especially with the big numbers. Bring down the first number, multiply. You get, everybody?
Negative 6.
Negative 4, that was one person. Let's try this again. Out of those, you get 0. Negative 4 times 0 is?
0.
Thank you. Bring that down. Negative 4 times 1 is?
Negative 4.
Negative 6 minus 4 is? Negative 10. Thanks a lot, book. You deceived me. So that's somewhere down here, right? So what does our graph look like? Well, I'm just going to try and connect the dots a little bit. Okay, so this kind of comes down here, but then it has to go back up here. This guy has to end up here somewhere, so maybe it crosses there and then it goes down. All the interesting stuff happens within this radius of 7. What's uninteresting, where it just goes off to infinity. I don't really care about that. Okay, it just happens.
So how many times do you have to do that?
So if you have an x cubed, you would expect 2 turns. So until you capture both of the turns. Okay. So like try every other number, see if you can get a good shape, and go from there. Since you have your calculators, you can always go back and check with your calculator. Okay, pretty horrible. How do we find the region of interest? Take the biggest number and add 1. Question.
How did you?
Whoa, this is so weird. Never gotten a question before on PreCalc.
For this, like the synthetic division thing, do you just plug in whatever number that you want?
Yep, and that gives you the value, the remainder is the value of that function.
Okay.
Isn't that cool? It's like a cool party trick.
Bless you.
Okay, what's the region of interest for this one? Region of interest is the, who hasn't communicated? Christian. 4, right? Biggest number is 3. So everything happens within a radius of 4. So you would want to plug in points like negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. How many turns do we expect? If it's an x cubed, the highest number of turns is, Victor?
I'm sorry?
The highest number of turns of our function, where it like, we did an x cubed right there, so that would help.
Oh. 4? No.
How many times does it turn? Twice, right? So whatever the highest power is, it's always 1 less on the number of turns. So like an x squared only turns once. X cubed usually turns twice. X to the 4th, 3 times, and so on. So once you capture those turns, you've got a good sketch. Cool, that's the lesson. You thought I wasn't into it. You were like, no.